Let's work another example. F of x is the function x squared minus 9 over x minus 3. We're asked to evaluate a limit as x approaches 3 of that function. And then, given an epsilon equal to 0.2, we're supposed to find that number delta bigger than 0 so that, and I have dot, 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 so that the absolute value of f of x minus L is smaller than epsilon whenever 0 is less than the absolute value of x minus c is less than this number delta, thinking about the definition of limit. Well, to evaluate this limit, I have to do some algebra first. Just remembering the things we did in our first week of class. Do a little bit of factoring. Cancel out that common factor, and I'm really just taking the limit as x approaches 3 of x plus 3, and I get 6. All right, there's my value c, x is approaching c, and there's my limiting value L. All right, f of x minus L is supposed to be less than 0.2. My function, well, is that function minus my limiting value that we found is less than 0.2. Well, nicely, I can do this same algebra I did up here. I can cancel out the common factor, which would tell me that x plus 3 minus 6 is less than 0.2. X minus 3 in absolute value is less than 0.2. And here comes that trick where we just rewrite it without the absolute value. The eagle-eye student right now already sees what delta is, but again, I'm going to work through it the way that will always work. And here is my interval of x. If I keep my x's on this interval, I will get y values that satisfy this equation. And now I just need to remember that delta is always a positive distance. On the x-axis, I would have the real number 3 that I'm supposed to be approaching. And here is my top end and the bottom end. And what I see is that on either side I look, my endpoints are 0.2 away from 3. So far in my examples, we haven't had to consider that case where the distances are different on the left or right. We'll do that in our next example. But here, if you tell me that epsilon is 0.2, the corresponding number delta is also 0.2. Again, we haven't really proven that this limit exists using the definition, because I'd have to convince you that for every epsilon you ever give me, there would be a delta that works. More examples to come.